We now discuss the solution of a problem from the section Differential Equations. This problem is related to homogeneous differential equation. This problem has appeared in the joint entrance examination main held on 28th June 2022 in the first shift. The given question is, let the solution curve y is equal to y of x of the differential equation. This is the differential equation. Pass through the solution curve y is equal to y of x of this differential equation. Pass through the points 1, 0 and 2 alpha, alpha, where alpha greater than 0. Then alpha is equal to. We are given 4 options. So option A, B, C, D. So we are given a differential equation, and the solution curve of curve y is equal to y of x of this differential equation passes through the point 1, 0 and passes through the point 2 alpha, alpha, where alpha greater than 0, required to find the value of alpha. We now discuss the solution of the problem in detail. The given differential equation is this one, that is in brackets x by under the square root of x square minus y square plus e power y by x bracket close x dy by dx is equal to x plus in brackets x by under the square root of x square minus y square plus e to the power of y by x bracket close multiplied by y. Agreed. Now look at this x by root of x square minus y square. Now if you take this x in the numerator into the denominator, then it can be written as 1 by under the square root of x square minus y square by x square, that is 1 minus y square by x square, that is 1 minus y by x whole square. Agreed. So what are we trying? That means we want to write everything in terms of y by x. So this can be written as, this first one can be written as in brackets 1 by under the square root of 1 minus y by x whole square plus e to the power of y by x into x dy by dx, x plus this also like this written. Then we divide throughout by x. So if you divide throughout by x, this will be 1 here, x by x 1, and y by x, it will be y by x. So what is that we got? We got in brackets 1 by under the square root of 1 minus y by x whole square plus e power y by x into dy by dx is equal to 1 plus the same factor here into y by x. Now if you want to get dy by dx will be this right hand function by this one. So that means dy by dx is a function of y by x. Dy by dx is a function of y by x. Such a differential equation is called homogeneous differential equation. So it is a homogeneous differential equation. To solve such a homogeneous differential equation, we substitute y is equal to vx, where v is a function of x. Put y is equal to v of x. Now differentiate. Dy by dx is equal to v plus x dv by dx. Y is equal to vx, where v is a function of x. Then this above equation, wherever there is y by x, you write v, and for dy by dx, you write v plus x dv by dx. So that will be in brackets 1 by under the square root of 1 minus v square plus e to the power of v bracket close. For dy by dx, in brackets v plus x dv by dx, 1 plus in brackets 1 by under the square root of 1 minus v square plus e to the power of v into v. Now multiply. If you multiply, you will get So this one into first v, and the bracket the first one into x dv by dx. So 1 plus this one. So this red one is a common. So both sides it is one and the same. Cancel throughout. Then you will get a differential equation 1 by under the square root of 1 minus v square plus e to the power of v bracket close x dv by dx is equal to 1. So this is another differential equation we got. So we will now solve this and substitute back v is equal to y by x. Then we will get the solution of the given differential equation. So we have this one. Now we will solve this one by the method. The first method what we learn in differential equations is the variables separables method. That means we separate the variables and then integrate. So if you separate, then it will be integral of 1 by under the square root of 1 minus v square plus e to the power of v in brackets dv. So v terms on one side, integrate is equal to x terms on the other side. That is integral dx by x plus c, where c is the constant of integration to be evaluated with the given condition. Agreed. So the integral of 1 by under the square root of 1 minus v square is sine inverse v plus integral e to the power of v is e power v only is equal to integral dx by x is ln x plus c. So you will get this one. Now substitute back v is equal to y by x. This will imply sine inverse y by x plus e to the power of y by x is equal to ln x plus c. And this is called the general solution. This is the general solution of the given differential equation. And the so-called the solution curve is y is a function of x. This is the solution, general solution, and it represents a curve and called a solution curve. Agreed. And it is given that this solution curve passes through 1, 0. That means put x is equal to 1, y is equal to 0 in the above equation. We get y by x will be 0 by 1 is 0. So that is sine inverse 0 plus e power 0 is equal to ln of x is 1 plus c. And sine inverse 0 is 0, e power 0 is 1. So ln 1 is 0, c is equal to 1. Thus we got c is equal to 1. Substitute back c is equal to 1. Then we get the particular solution of the given differential equation. So in the place of c, we write this particular value, c is equal to 1. So sine inverse y by x plus e to the power of y by x is equal to ln x plus 1. This is also a curve, but it is one member of the given family of curves given by this one. So this gives rise to a family of curves, and this is a particular curve with this property. Agreed. Agreed. We continue in the next slide. So we have this one, and it is given, it passes through 2 alpha comma alpha, where alpha greater than 0. Alpha is a real number greater than 0. So then required to find the alpha. Required to find the value of alpha. So put x is equal to 2 alpha, y is equal to alpha, where alpha is a positive real number, and these values you put in the above particular solution. Then we get sine inverse y by x, that is 2 alpha by alpha, that is alpha by 2 alpha. Alpha cancels because alpha greater than 0. So you will get 1 by 2. So e to the power of y by x is 1 by 2 is equal to ln of x is 2 alpha plus 1. So sine inverse of 1 by 2 is pi by 6 plus e power 1 by 2 is root e minus 1. This plus 1, send it to the left hand side. Then it becomes minus 1 is equal to ln of 2 alpha. Now get rid of this ln. So you will make an exponential. So this will imply 2 alpha is equal to exponential of pi by 6 plus root e minus 1. And we want alpha. Alpha is equal to 1 by 2 into exponential of pi by 6 plus root e minus 1. Let's look at our options. our answer for the alpha appears against option A. Therefore, the solution for this problem is option A. The answer to this problem, the solution for alpha is 1 by 2 into exponential of pi by 6 plus root e minus 1. That is precisely option A. Therefore, the answer to this question is option A. So that is the detailed discussion of the solution of the problem, which is based on the concept of homogeneous differential equation from the section differential equations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.